Hello friends, in this video let us derive the formula for area of a triangle. So in our earlier classes we have learned the area of a triangle formula as 1 by 2 into base into height. So in this video let us derive the formula when the coordinates of the three vertices of a triangle is given. So here let me explain you with the help of a diagram. So let's ABC be the triangle having the vertices A, B and C with the coordinates x1, y1, x2, y2 and x3, y3. So here let me derive the formula using the trapezium concept. So here area of a triangle ABC is obtained by adding area of a trapezium ABQP, area of the trapezium APRC minus area of the trapezium BQRC. I have just written it here. ABQP, APRC minus BQRC. So what is area of trapezium formula? Area of a trapezium formula is nothing but 1 by 2 into sum of parallel sides into distance between the sides. Okay. So let's do it for the first trapezium. So after that second trapezium, after that third trapezium. Clear? So for the first trapezium ABQP, for this ABQP, what are the parallel sides or nothing but BQAP are the parallel sides. We have to do sum for parallel sides and the distance between these two parallel sides is QP. Correct? So the distance between the two parallel sides will be QP. So here that is equals to 1 by 2 into BQ plus AP into QP. What is this? Area of the trapezium ABQP. Put this as equation 1. In the same way, let's do it for trapezium APRC. So let's write it here. Area of trapezium APRC equals to 1 by 2 into. For trapezium APRC, let's see, this is the trapezium APRC. What are the parallel sides or nothing but AP and CR are the parallel sides. Let's do the sum. 1 by 2 into AP plus CR into what is the distance between these two parallel sides is nothing but PR. Correct? So into PR. So put this as equation 2. And the same way let's do it for area of trapezium BQRC. Area of trapezium BQRC is nothing but what are the parallel sides here? BQ and RC are the parallel sides. 1 by 2 into BQ plus RC into distance between these two parallel sides is nothing but QR. Correct? Into QR. So into QR, put this as equation 3. The next step, what do I do? Find out the values for BQ, AP, QP, all this in terms of x1, y1 or x2, y2 or something x3, y3. So first thing BQ. So what is BQ here? From the diagram, we have to find out this BQ. BQ is nothing but the distance. So BQ is parallel to y-axis, right? So when a line is parallel to y-axis, the distance between B and Q is nothing but what? So it's y2. Correct? Distance is y2. Okay. And the next one AP. So in the diagram, what is AP? AP is nothing but this. So this is also parallel to y-axis. It's nothing but, what is this? AP is nothing but y1. Correct? So here it becomes AP is y1. The next one, what is that? QP. So what is this QP here? QP is, let me write the points here. So when a line is parallel to y-axis means what here? X coordinate remains same from the vertical point of view, and so the point at Q will be x2, 0. In the same way, let's write the point at P. So P will be x1, 0 because this forms x-axis and this is y-axis, right? So here x, y and x dash, y dash. So it becomes x1, 0. In the same way for for R it becomes x3, 0. Okay. So they asked us to find for next one is QP. QP means nothing but this you want. So from origin to the point P the distance will be x1. So here this entire distance it will become x1, but they asked us to find only this QP. So from origin to Q, this distance is x2. So what does this will be? This will be nothing but x1 minus x2. So this QP distance is nothing but x1 minus x2. So let's write the same way here. QP is x1 minus x2. The same way, what is AP here? From the diagram, when you see AP, this entire line is parallel to y-axis, right? So AP is nothing but y1. AP is y1 here. So again AP y1. Here I have just written whatever was there. I am just putting it here and writing. What is CR? CR. Let's see. CR. It's again parallel to y-axis. CR is nothing but the distance between from point C to here. So when you see here, x coordinates is same. So the distance will be y3. So let's write it here. CR is nothing but y3. What is PR? PR, when you see in the diagram, what is PR? So from here to here distance. So from origin to the point R, what is the distance here? So from origin to the point R, the distance is x3. So they want only this PR. So from origin to the P, it is x1, right? So this point will be, PR distance is nothing but, it's nothing but x3 minus x1. So PR is nothing but x3 minus x1. So let's write the same thing here. PR equals to x3 minus x1. Correct? So after that, BQ. Let's see what is BQ here from the diagram. So this B is here, right? So BQ they want. So BQ is again parallel to y-axis. The distance is nothing but y2. Correct? So BQ equals to y2. Y2. So here what is RC? So RC. CR and RC is same. That is y3. Here we have written it anyway. So RC is y3. RC equals to y3. The same way, what is QR? QR we want. What is this QR here from the diagram? From here to here. So distance between from Q and R. So this entire distance is x3. But we want only this Q and R. So we have to separate only this OQ part. So let me write it here. QR I have written it as OR minus OQ. So what is here OR? So OR is x3, OQ is x2. Correct? So let's write this here. It becomes x3 minus x2. Correct? Therefore, area of triangle ABC equals to equation 1 plus equation 2 minus equation 3. Let's write the same thing here. 1 by 2 into BQ plus AP, 1 by 2 into BQ plus AP into QP plus 1 by 2 into AP plus CR into PR minus 1 by 2 into BQ plus RC into QR. Correct? So in the next step, what do? I just write this whatever was there. I am taking 1 by 2 common. Let's write everything inside the brackets. So BQ plus AP into QP plus AP plus CR into PR minus BQ plus RC into QR. Let me continue this in the next page. Yes. So here BQ plus AP into QP, AP plus CR into PR minus BQ plus RC into QR. So here I have written the values in the previous page we have done, right? Like BQ value we have put it as y2 or something. So I have just substituted the values whatever we have derived in the previous page in this formula. So the next, so when you see here this is all jumbled. So let us put it in a particular order. So x1 into, so what are there in terms of x1? So this entire thing comes in terms of x1, right? So y2 plus y1. So here again x1 minus x1 is there, right? So when you take x1 common, minus into y1 plus y3. So minus of y1 plus y3. So this will come for x1. So here it's x2, x3. So you should not consider that. Plus x2 into, so what is there x2? Minus of y2 plus y1. Minus of y2 plus y1. And here Did you see any x2? No, here it will be there. So minus into minus it becomes plus, right? So plus of y2 plus y3, correct? So we have taken x1 common, x2 also we have taken common. In the next x3 I'll take common. So this entire thing no x3. So when you see here x3 is there. So inside brackets what do you get? y1 plus y3. Here also x3 is there. So minus into plus it is minus of y2 plus y3, right? So let's simplify this. So 1 by 2 into x1 into y2 plus y1 minus y1 minus y3, again plus x2 into minus y2 minus y1 plus y2 plus y3, again here plus x3 into y1 plus y3 minus y2 minus y3, correct? So here y1 and y1 will be cancelled off, again here y2 and y2 will be cancelled off, again here y3 and y3 will be cancelled off. So what do we get? 1 by 2 into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So this is the formula for area of a triangle ABC when the 3-point coordinates are given. Clear? So this is the formula derivation. So 1 by 2 into x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. So I'll tell you a small logic how to remember. So here 2, 3, after the continuation 3, 1, after that continuation 1, 2. Clear? So this is the easy remembrance of formula of area of a triangle ABC. Clear? So this is the solution. I hope you like this video. In case you like the video, do like, share, comment and don't forget to subscribe to my channel. Thank you.